Alright, see Lindelof videos, increasing and decreasing intervals on an absolute value function. Here we have an absolute value function. In the last video I left all this up and showed you that if this was a multiple choice question and I didn't have to provide proof, what I would have done is I would have graphed this absolute value function and seen what it did, and I would have moved stuff around and put this into vertex form, and we would have gotten somewhere with this. However, that's not always possible, and sometimes they're going to want proof. So what I'm going to do is this. And here's the proof that I'm going to offer you. And this proof is based on something that Martha Claybrook actually did. But let me just, I hope she doesn't mind me expanding this a little bit because it expands. I can rewrite this function. I can say f of x is equal to 5 minus, x minus 5 squared, the square root of that. Now I know what you're going to want to do. You're going to want to actually cancel these two things out, and they do. However, what you will get here, if you do it this way, is that you'll always get a positive number. So I'm asking you to look at it this way, and let's see if we can't take the derivative using the chain rule. So I'm going to rewrite again. I'm going to say f of x is equal to the opposite of x minus 5 squared to the 1/2 power, right? Plus 5. I'm going to take the derivative, so I'm going to go ahead and start to differentiate here. Don't clean up the math. I just want you to show you what this proof would look like so you can actually come up with this derivative. I'm going to multiply 1/2 times negative 1 in this case and get negative 1/2, right? X minus 5 squared, right? To the negative 1/2 power, right? Times the derivative of the inside, and the derivative of the inside is 2 times x minus 5, isn't it? To the first power, and the derivative of that inside piece is 1, but it doesn't affect us, so we can stop. We don't have to use that chain rule that many times. So I'm just asking you to take a look at this for a second. So I'm actually not going to clean this up. I'm going to say f prime at x is equal to, this negative sign is this one, and at the bottom I have this 2 is this one. We have x minus 5 squared to the 1/2 power. And at the top we have 2 times x minus 5, right? I see some temptations that maybe you want to distribute into here. I'm asking you not to. But I will clean this up and say these two things cancel. Remember to keep your negative sign here because it was there. Now all I'm asking you to do is this, to think about this carefully, because we talked about this at the beginning of the video, didn't we? Didn't we? That the absolute value of u, because this is not x, this is u, is equal to u squared, the square root of that, isn't it? And then if we did that, this would just turn into u, wouldn't it? But let this be the definition of absolute value of u. So look at this for a second. If we go back here at the top, we keep our x minus 5. There's our solidus. Our negative sign is here. But by definition, if I raise something to the second power and raise that to the 1/2 power, I get absolute value, don't I? So we get absolute value of x minus 5. We can see clearly here that the function is undefined at x, so it's undefined at x is equal to 5. So we know that any place the first derivative goes undefined, that becomes a critical value, doesn't it? So it's the only critical value that we have here. So we just have two intervals. So we just have two intervals. So I'm going to write down interval. Whoops. I'm going to write down interval. I'm going to write down sine of f of x on that interval. And the conclusion that I come to. Conclusion. This is the way it should be set up on the AP exam. But there are only two intervals here, right? We have x is greater than negative infinity to x is less than 5. Then we go from x is greater than 5 to x is less than positive infinity. Isn't that right? So from there, we just pick some value. Pick some value here. And any value that you put in this case, will give you f prime at x is greater than 0. Increasing. And any value that you put in this interval will give you f prime at x is less than 0. And this is what your reader wants to read on the AP exam, and what your conclusion was, and this one comes to decreasing. So we can tell that this is a maximum, and that makes perfect sense, because if you look at this function, frankly, if you look at this function here, when we graph this, it is an absolute value function, and it looks like this, and this is the point 5, 5. Look, you guys, I hope this was helpful. I want to thank those people who helped me put this illustration together. I appreciate it. If you haven't already subscribed, please do. Thanks.